Hello everyone, this is the first part in a series of videos talking about doing a design review on schematics. What we have in front of you here is a simple schematic that we're using for junior design. It's a switching power supply and a linear power supply. It has a 5-volt regulated output for the switching supply at 2 amps, and then the 3.3 volt supply is around 800 milliamps. It's supposed to be around 800 milliamps with an input of around 5 volts or higher. So that's kind of the details of this. What we're going to do is we're going to go through the process I would go through to double check that this schematic is successful and will be buildable. And then after that, we'll double check the bill of materials. Actually, we might do it in conjunction. And then in a later video, we're going to review the board layout, the PCB layout itself, and what I would look for in that. So let's dig into this thing. So this particular thing is kind of in 2 parts. The switching supply that we're choosing to use is a TPS 54232, which is a Texas Instruments part. A great little chip. I've used it many times in the past. There are newer chips and newer models that are more efficient. I like this one primarily because it has a very nice data sheet that's complete and can really walk you through the process of designing it rather than expecting you to kind of know how it works from the get-go. In terms of the linear part that makes our 3.3 volt output, we're going to use an LD1117. This is a part that I've never used before. It seems to be a simple 3-terminal device. Has a pretty good dropout, so you can put in a pretty low input voltage and still get your 3.3 out. Also looking at all these connectors, we have a variety of ways you can power this system. You see we have a DC jack over there on the side that allows us to do a 2.1 millimeter barrel plug. We have a jumper connector. We have an enable switch, which will hopefully, if this has been done right, switch off and on the 5-volt regulator, as well as we can control that from a microcontroller or something with a jumper. On the 3.3, we have an interesting input, which is that 3-terminal connector, here. And that connector allows for you to install what's called a suitcase jumper to either power this 3.3 volt part from this 5-volt regulator or from somewhere else, and that somewhere else being this 2-pin power connector. On the output side, we have 2-pin jumper headers for both the 5-volt and 3.3 with an extra ground, and we have a 3-pin JST PH style connector. This is a more commercial looking connector that would allow us to use this to power something else. So that's kind of our design. The problem is I don't know if this works. Usually what I would do is I would break the circuit down to pieces so that I can research each piece. So we're going to start with this regulator down here, the 3.3 volt. And to do that, we'll jump over to the data sheet for it. Now, how do I find this data sheet? How do I know the data sheet for this part? Well, there's also a bill of materials for this, which I can find right here. And so this is a bill of materials that was generated. I would always have this open as well as the schematic and then a web browser so that I can start hunting for things. And in this case, I found that this part right here has this voltage regulator, and this is the link that I followed to get the data sheet. Now, when I follow this link, I am going to verify a couple things. One, I'm going to make sure that the manufacturer's part number, MPN here, is actually this number. That's important because I've seen many times where because you do a change, you cut and paste, you move some stuff around, you actually end up ordering a part that's close, but maybe has the wrong package type, or maybe is you have to order a reel of them, or something along those lines. So we want to be really sure that this is the correct part number. I'm also going to verify this DigiKey part number just to make my ordering easy, but the key thing is the manufacturer's part number. So that's an LD111737S33TR. So if I jump back over and I check that out here, sure enough, that matches the manufacturer's part number. Sure enough, it's the part I'm expecting it to be. Available here at DigiKey, pretty inexpensive, 46 cents for one, 37 cents or so for 10 of them. Data sheet's right here, so we bring that bad boy up. One thing, I don't usually recommend you use your web browser to actually look at data sheets. I recommend you actually download them and then open them with Adobe PDF. The reason that is, you'll see if it's enabled, I have the page thumbnails. I should also have bookmarks and a table of contents so I can just jump to sections rather than having to scroll through. So that's a very important thing. So there's my internal diagram of the system. Real quick, I always look at the features. So it's low dropout, 2.85 volt device performance. So it can do 2.85 volts on one of the versions. You can do fixed outputs. You have adjustable outputs, so on and so forth. But let's see if we can figure out if they give us an application schematic. And sure enough, they do. So this is a figure 4 application circuit for other fixed voltage outputs. So V in, V out, 10 microfarads, 100 nanofarads. All right, so if I jump back over and look at our schematic, it looks like I got the 100 nanofarad, 10 microfarad. I got my ground reference, great. I got my input and my output going the right direction. Now, I'm not checking the pin numbers here. This particular part does have pin numbers right now, but those aren't important at the time of looking at the schematic. Where they're important is when we start to look at the PCB. So in our next video, we'll actually double check that we've wired the leads that are on this schematic symbol properly to the leads that are physically pieces of copper, the copper pads on the circuit board itself. So we'll check that in a later video. Okay, now in order to make this thing run, we need a 1N, we have a 1N5819 here in the beginning. This is really designed to make sure that we can't hook up power backwards or in reverse. So it's often called an idiot diode. I think it's a great thing to have. But if this system is going to be 0.8 amps, we need to make sure that this 1N5819 can handle that level of current. So to do that, we'll grab that data sheet, which I just happen to already have open. So here's your 1N5819. If we scroll down, it looks like it can rectify 1 amp. Now, you can choose to trust DigiKey if you'd like. That being said, I always like to go to the actual data sheet just to be sure. I have had mistakes happen in the past. So 40 volts RMS, or reverse bias, excuse me. Looks like 1 amp forward current. So it looks like it's spec'd for what we're doing. And it's only going to drop 450 millivolts at that 1 amp. So great. So back to our verification here. So for me, that means we're done and we're done. And so I like to either print this out and actually write on a physical piece of paper. That's what I would normally be doing. But for this video, I wanted to make sure that we had something that was easier to record. And so I'll probably find a way to highlight here. There's got to be a way to highlight here. Hey, let's try that. And I'll just highlight. Nope, not going to be that nice for me. Oops, done. Okay, and we're also going to verify this guy as done. Okay. Now these two values, so they are the proper value, what's specified here, but let's go make sure that the bill of materials has them right. So if we jump over and we look for the 100 nanofarad, where was I? So C1 and C3, 100 nanofarad and 10 UF. So C1 and C3. Jumping over here, we got C1, 100 nanofarad, good, and C3, 10 microfarad, great. We have their footprints, so we know one's going to be an 0603 and one's going to be an electrolytic, but it looks like we can't verify C1 because we don't know what part's actually planning to be used. We can verify C3, however, so we're going to just go double check again that we have the right manufacturer's part number and that we're at the right DigiKey part. I know this might seem pretty arduous to kind of go through this step by step, but the beauty of this is you only really have to do it once, because once you've verified that a part is correct, as long as you don't delete it or move it or change it, that's verified. And so you don't have to touch it again. Looking at this one, yeah, we do have the right value. It's 35 volts working voltage. So this is on the output of a 3.3 volt regulator, because this is the 10 UF, just to remind you of that. 10 UF, it's on the output. So it should never see a voltage more than 3.3 volts. Jumping back over though. Looking at our layout, we're going to go ahead and verify that in a later video, but it looks to be the right part. That being said, we do have a slight problem that this part here is not on the BOM. And versus here. Done. Okay, so those have been verified. So good, so that's the simplest piece. So that's gonna be kind of the end of this video, and we'll jump back over and we'll start going through this top regulator here in just a few moments, and we'll be spending a little bit more time actually analyzing the circuit and making sure that we've done our calculations properly. Okay, great guys, we'll see you in the next video.